Picture this. It's 2 a.m. Your production app stops responding. No error message, no crash log, just completely frozen. Your phone blows up with alerts. Then you restart the app, it works for 5 minutes, then freezes again. You finally take a thread dump and you see two threads, each holding a lock the other one needs. That, my friends, is a classic deadlock, and it happened because of a simple synchronized block. I have been there. It's not fun. But here is the good news. Java gives you a whole toolbox of locks, not just synchronized. And once you know them, you can build concurrent programs that are not only correct but also scream in performance. Today, we are going to cover everything. We'll start with intrinsic locks, the good old synchronized. Then we'll move to explicit locks like reentrant lock with all its superpowers, timeouts, interrupts, and fairness. After that, read write locks when reads dominate. Then the game changer, stamped lock with optimistic reads that can be 5 times faster. And finally, condition, the modern, cleaner way to make threads wait for each other. So let's jump in. Simplest lock in Java is built into every object. You have used it 1,000 times. That is intrinsic locking. We have used synchronized method or synchronized block. And when thread enters a synchronized block or method, it acquires the monitor lock of that object. And when it exits, even if an exception is thrown, the lock is automatically released. No finally needed. That's convenient and safe. But synchronized has some painful limits. First, you cannot interrupt a thread that's waiting for a synchronized lock. It will wait forever. Second, there is no way to try to acquire the lock with timeout. You either get it instantly or you block indefinitely. Third, if you need to wait for a condition like buffer not full, every thread that calls wait method ends up in the same waiting pool. You will see why that's a problem when we talk about condition. So for simple cases, synchronized is great. But when you need more control, you need explicit locks. Explicit locks must be manually acquired and released, giving developers fine grained control. Advanced features like timeouts, interruptibility, fairness policies, and multiple condition variables. Here are common explicit lock types. First, reentrant lock, which implements lock interface, which is general replacement for synchronized with more control. Reentrant read write lock, which implements read write lock interface. We can use it when reads dominate, allows concurrent readers. And last, stamped lock, which supports optimistic reads 5 times faster in read heavy workload. So let's move on to see how to use reentrant lock. Before moving to reentrant lock, let's see what the reentrancy really means. Reentrancy simply means that a lock recognizes the thread that already owns it and it allows same thread to acquire it again without blocking itself. In Java, Both synchronized keyword and reentrant log, as name suggests, are reentrant. This prevents accidental self deadlocks when one synchronized method calls another. Because the thread can safely re-enter the lock it already holds, the lock keeps count of how many times it has been acquired, and only when the thread releases it the same number of times it is truly unlocked. In practice, this makes code modular and safe, but it also demands discipline. Every lock must be matched with an unlock. Forgetting that balance can lead to subtle bugs or deadlocks. Unconditional lock acquisition. This is how you create reentrant lock. Before executing the critical section, you attempt to acquire a lock without any condition. And once you execute critical section or you get an exception, you eventually reach the finally block. Notice this. You must unlock manually. If you forget it, the lock stays locked forever, a ticking time bomb. That is the one reason synchronized is still popular. It can't leak locks. But with great power comes great responsibility, right? The first superpower of reentrant lock is this try lock method, which is polled lock acquisition. You can attempt to grab the lock if it is available immediately. You acquire it, but if it is not available, you don't wait for a lock. You can simply get out of it and do something else. Even better than this, you can give it a timeout, which is timed lock acquisition mode. Here, we try to acquire a lock waiting up to 1 second. If the lock is available, it returns true immediately. If not, it waits up to 1 second before returning false. Now, here is a real world example. This method transfers money between two accounts. It takes source account and destination account and the amount. Here we have infinite loop that keeps trying until either we get success or you can add timeout if you need. First, we try to acquire a lock on source account. tryLock is non-blocking. It succeeds immediately if the lock is free, otherwise fails. If source lock was acquired, then try to acquire destination lock. This ordering prevents deadlock by always locking accounts in consistent sequence. Once both the locks are held, check if source account has enough funds. If not, throw an exception. Otherwise, debit the source and credit the destination. Return true to signal success. Finally, this block ensures the destination lock is always released. Then release the source account lock no matter what happens inside. Another superpower, lock interruptibly. This lets you acquire a lock while still being responsive to interruption. This is interruptible lock acquisition mode. If another thread calls interrupt method on your thread while you are waiting for a lock, the method throws interrupted exception and you can gracefully cancel. This is essential for building cancelable tasks. Imagine a user click cancel download button. You want the downloading thread to stop waiting for a lock and exit cleanly. With intrinsic locks, acquire and release pairs are block structured, meaning a lock is always released in a same basic block in which it was acquired, regardless of how control exits the block. Atomic lock release simplifies analysis and prevents potential coding errors, but sometimes a more flexible locking is needed, and that's where non-block structure of reentrant lock helps us. Non-block structure locking means that lock acquisition and release are not tied to a code block like a method or pair of curly braces. You can call lock method in one place and unlock it in a completely different place across method boundaries in different scopes or conditionally. Reentrant lock constructor offers a choice of fairness. You can create a non-fair lock, which is the default one, or fair lock. The threads who acquire a fair lock in the order in which they requested it, whereas a non-fair lock permits bargaining, meaning threads requesting lock can jump ahead of the queue of waiting threads if the lock happens to be available when it is requested. Wouldn't we want all locks to be fair? After all, fairness is good and unfairness is bad, right? When it comes to locking, fairness has a significant performance cost because of the overhead of suspending and resuming threads. One reason bargaining locks perform so much better than fair locks under heavy contention is that there can be significant delay between when a suspended thread is resumed and when it actually runs. Let's say thread A holds the lock and thread B asks for that lock. Since the lock is busy, B is suspended. Now, when thread A releases the lock, B is resumed, so it can try again. In meantime, though if thread C requests the lock, there is good chance that C can acquire it, use it and release it before B even finishes waking up. In this case, everyone wins. B gets the lock no later than it otherwise would have. C gets it much earlier than B, and throughput is improved. Non fairness improves throughput because you avoid the overhead of context switching. That's why the default fairness policy is non fair. And also make a note of this that synchronized keyword also works like a non fair lock. So, when to use reentrant lock? Rule of thumb is use synchronized unless you need timeouts, interruptible waits, fairness, or non block structured locking. Reentrant lock is more powerful but also more dangerous. You can forget to unlock, so don't replace every synchronized with the reentrant lock. Use it only when You need what Synchronized can't give. If you found this video helpful, please give it a thumbs up and subscribe for more technical content.